All right, so today I'm going over conditional identity and contradiction equations. So we've been solving equations. Last week we were learning the basics of solving, and then this week we're introduced to different types of equations or different types of solutions that you can get when you are solving. So when solving, there's basically three possibilities. You can get a number for your answer. And when you solve an equation, you actually get a number that is called a conditional equation. It's possible to get no solution to an equation, and that is called a contradiction equation. And then it's also possible to get infinite solutions, which basically means there are lots of answers to that equation, and that's called an identity equation. So these are the three categories. So most of the time, it's a conditional equation. If you make up an equation and then try to solve it, generally it's going to be a conditional equation. It's very hard to make up an equation and then have no solution or infinite solutions. So this is usually what you get, and that just means when you solve, you actually have an answer. And so there's a number that makes that equation true. Later in the class, we'll learn about quadratic equations where there are two solutions to an equation. Right now we're just dealing with one. So there are some numbers that make the equation true and some that don't. And so it's called conditional because it's true on the condition that your variable x is equal to this particular number. So if you solve an equation, you get x equals 2, the equation is true on condition that x equals 2. So you want to be very careful, especially when you're in Connect Math and you are, typing in your answers. You want to pay attention to the wording of the question. So if the question just asks for a solution or for you to solve, it's completely fine to write your answer exactly as you would be when you solve. So like maybe you solve it and you got x equals 2. That's totally fine. You can write that on paper. That's perfectly fine and accepted. Sometimes you'll get a question that asks for the solution set. And as soon as it says set, that's telling us that we want to use set notation, which uses the curly brackets. And so you would be putting your answer inside a set. So if you solved x equals 2 and it asks for the solution set, you put the number 2 inside your curly braces or curly brackets. So you want to be careful when you're answering questions in the online system, because sometimes it might give you the variable and say x equals, and then you fill in the number. Sometimes it wants you to put the equation in, and then sometimes it wants its solution set. You can usually tell if it wants the equation if when you kind of click in that box, if the equal sign pops up. So if you click in the box and it has those buttons that you can choose, if one of them is equal sign, it's telling you type in the equation. If there's no equal sign in that box, then you're going to want to see, does it say solution set? Then you need to use that set notation. Sometimes they give you the curly braces and you just plug in the numbers. Sometimes you don't and you need to type in the curly braces. So you have to kind of pay attention to what it's giving you, what is already there. Where is the box? Is the box inside curly braces or not? So you know which way to write the answer. And this is just particular to the computer system and what it is looking for in the way it's coded. If you're writing things on paper, it doesn't matter whether you write it as x equals 2 or you have the curly braces with 2, whatever your answer is, that doesn't matter. But just for the online system, because it's coded a certain way to expect certain inputs, you have to know what is the wording, what is it looking for, so you can make sure that you put it in the way that it's looking for, what it's looking for. So that's conditional equations. These are contradiction equations. And so the contradiction is when there's no solution. Basically, you've set something equal that's not actually equal. So it isn't true. It's a false equation. What happens when you're solving is that your variables will disappear. If you're moving x from one side to the other side of the equation and you get 0x, you don't have your variable at all, it's gone. And then you look at what's left and you're going to have two numbers and you're going to get something that's false. So if you solve, then you end up with the equation 0 equals 3. Well, we know that 0 does not equal 3. That's plainly false, not true. And so that means there's no solution because you got a contradiction. You didn't get the left side equal to the right side. They're not equal to. So on paper, you can write no solution. Sometimes on the online system, there will be like bullets or like you get to choose a button. What type of equation is this? What are the solutions? So sometimes you'll choose like there's no solution. There's a symbol here. It's basically a 0 with a slash through it, and that means empty set. So that means that there's no solution. There's no numbers that are in the solution set. Otherwise, if it asks for the solution set specifically, you just kind of leave it blank and you just have the curly braces with nothing inside. So those are kind of shorthands for writing no solution, because no solution can get kind of, it's easier to write a 0 with a slash through it. But you want to be careful. This is why sometimes I see people in their normal handwriting write zeros with a slash on it, and I say don't do that in math, because that actually means it's a specific symbol in math. So in math, when you're writing your zeros, never put a slash through it, because it actually means something. It means empty set. So that is a symbol used for something else. But basically, when you're solving, you get no solution. Your solution set is just empty. There is no number that works. Then we have the identity equation. And this basically is the type of equation where your left side and right side are identical, hence the name identity. And you'll find that no matter what number you plug in for x, you're always going to make the equation true. So you can plug in any number you want and it will work in that equation. You can identify this type of equation when you're solving because your variables disappear, just like when you're solving the contradiction equation. But now you have an equation that's true. So you solve and you get 0, but you get 0 equals 0. Or sometimes you'll get like 10 equals 10. You get something where both the left side and the right side are equal. So when that happens, it's an identity equation. And so that means it doesn't matter what x is, because when you solve it disappeared, it's always going to be true. It's always a true statement. So there are different ways that you can write your answer. So you can write that there are infinite solutions, or we have this symbol R. I usually write it by hand like that. That's how I write the symbol by hand. And that is just the symbol that means all real numbers. Basically, your answer is every number you can think of works in the equation. It's all real numbers. Otherwise, this with the curly braces, if you were solving for x, you can write x. You have a vertical bar, and then you would say x is a real number. It's kind of lengthy to write that out, but that is called set builder notation. So if you see that, that is one type of writing your answer if there's infinite solutions. Otherwise, you can just write the solutions are, the solution set is the set of real numbers. And I believe that is how our online system wants it, is that you would literally type in the set of real numbers. And I think they might even have a button where you can just push it and it will enter that in for you. But when I'm doing it on paper, and like, let's say you're just, you're solving this on your own or something like that, I use the little shortcut for R because it's a lot quicker to write that than to write this whole sentence out with the solution. So those are the 3 different types of equations. Are there any questions before we get into some examples? Okay. So I've just got a whole bunch of examples here, and some of what I want you to do as you go through here is try to look at the equation and look at it and see mentally if you can decide before you start solving whether it's going to be conditional, identity, or contradiction. Now, you're not going to probably be able to do this from the very beginning, but as you get more familiar with equations and you kind of get an idea of what they look like, you can eyeball it. You can kind of see your equation if it's relatively simple. If it's like a really complicated equation with lots of parentheses and brackets, it's kind of hard to do. But smaller equations like this, you can kind of look at it and know right away if you're going to have an answer or not. Is it going to be condition, identity, or contradiction? But if you're not noticing that, that's fine. I just want you to get into that practice to kind of eyeball it and then solve it and see if you're right. So we're solving this equation, and the first step for solving any equation is to always do any distributing before you do anything else. So as soon as you see that there's parentheses you need to distribute, that's always the first thing that you're going to do. And actually, very first thing was we should rewrite our subtractions as adding negatives. I forgot that is actually the better first step. So first let's do that, and then we'll distribute. Because we want to make sure that we've got our equation in a way that it's easy that we don't make mistakes. So I've got 2, and then I have a k, so I'm going to just put a 1k there so we're very clear what numbers are multiplying. And then I have a -7, so I'm going to write that as adding a -7. And then I have 2k minus, adding a -13. So until you've gotten enough practice with equations, it's good practice to rewrite so that all your subtractions are adding negatives, and then any variable that doesn't have a number, you can put a number in front, put a 1 in front, so that we know what we're multiplying. Then we will distribute. So when we're distributing, we're taking this 2 and we're multiplying it through the parentheses, and I usually do the multiplication in my head versus writing down every single step. But if you're someone that needs to, make sure you've written it down and make sure you're multiplying the correct numbers, you can actually write it down. So that would be 2 times a 1k. And then we're also going to be multiplying that 2 by the -7. So it's better to write down more steps than you think you need just to make it easier to check for errors. And then as you get better at this and you get more practice, you can start skipping some of these steps and doing it in your head. So part of the distributing property is literally doing that multiplication. So we'd have 2 times 1k. And we use the associative property that we learned last week to basically just group. Instead of grouping the 1k together, you can group the numbers together, 2 times the 1. And so that is what allows us to actually multiply these together. So we get 2k plus, and then 2 times -7 is -14 equals 2k plus -13. So now I've distributed, and then the next step is to actually start the solving process. So, distributing is part of solving, but when we actually want to, after we've simplified each side, we want to solve, we want to get our variable on one side and the numbers on the other side. And it does not matter if you want your variable on the left or on the right. You just pick a side, basically. I just, by habit, always make mine on the left. And I always move my variables first so that I have those where I want them, and then I can figure out what else needs to be moved. So I always move the variables first. And so this is where we're going to add or subtract on both sides. So that is going to be step 3. And at this point, looking at what you have, you might be able to guess what's going to happen to our equation, whether it's going to be conditional, identity, or contradiction. So we want to do this to both sides. And actually, I'm going to just write add or subtract and put variable term there so I can kind of line things up. So math works very vertically. You're working from top to bottom on your page. You don't want to work sideways. It can make it very difficult to follow. So I want my k's to be on the left. So the k that's on the right, the 2k, I need to get rid of that. So it's positive. We always do the opposite. So we're going to subtract. And then I'm going to write it underneath the other k. So we're subtracting those k's. And then I usually draw a line here. And then we have 2 minus 2 is 0. So if you want, you can write 0k. And then we've got plus negative 14 equals negative 13. Because again, well, we could write the 0k plus negative 13. And anything with the 0 basically is gone, so you just have negative 14 equals negative 13. So our k's disappeared. When we subtracted, we got 2 minus 2, which is 0. They're not there anymore. And now we're just left with numbers. And so now we have to look at what we're left with. Does negative 14 equal negative 13? And they're not the same side. The left side does not equal to the right side. And what that tells us is that we have a contradiction because this is not true. So negative 14 is not equal to negative 13. And so the not equal symbol, sometimes it's a slash through the equal sign, sometimes it's straight up. Either way, it means not equal. And so this is a contradiction. So it's a contradiction equation, and then we would write our solution set as the empty set with basically nothing inside it. I'm going to use that symbols because I believe that is what Connect Math uses, as it literally just has an empty set. So if you're looking over this whole problem and thinking, well, how could you have determined that it was going to be no solution from the very beginning? Is I looked, well, let's look at this step right here. I can see right here that I have 2k on both sides, and so those are going to cancel out. And so I can see they're going to cancel out, but then I'm going to be left with negative 14 equals negative 13. So I can just visualize, knowing how solving works, I can see that, know that they're going to cancel, and then I'm going to get something that is not true. You can also identify at the initial step, if you think in your head, okay, we have to distribute, I'm going to get 2k on both sides because of the 2 times k. And then you just think in your head, okay, 2 times negative 7 is negative 14. I'd have negative 14 and negative 13. Those are not going to match. So you can determine whether you're going to have no solution at various points depending on looking ahead and understanding how the rules of solving goes, and then being able to see that, okay, the left side is not going to be exactly the same as the right, and we're going to get our the variable part is going to cancel. Basically, if you have the same number of variables on the left on the right, but the number parts, like the numbers by themselves, are different, you're going to get a contradiction. So if you kind of eyeball and kind of look ahead as you're looking at these equations, kind of doing a little bit of the multiplication in your head, you can see whether there's going to be solution, and then that could save yourself some time. If you looked and you say, okay, I know that this is going to be no solution, you don't even need to solve other than just to double check that you are correct. But otherwise you just go through the process, and then you basically come to the end, and then you can decide at the very end, once you have your variables are gone, you can say, okay, my numbers are not the same on each side, so this is no solution. Are there any questions? Okay. So here is another one. So let's have you guys make a guess here. Look at this equation, try to think ahead, maybe do a little bit of the math in your head. Try to say, is this going to be conditional, which means that there is a number solution? Is it going to be identity, which means that you're going to have the identical thing on both sides? Or is it going to be contradiction, where the left side is not equal to the right side? So just kind of make a guess, put it into the chat, and then we'll see if you're right. You can kind of make it a little game, you know? Think, do I know what the solution is going to be? Kind of eyeballing this, and then see if you're right. Okay, so Christy's got a guess of identity. So let's go ahead, and I'm going to remember first step. Let's rewrite everything. All those subtractions is adding negatives. Any variables, put a 1 in front. Gregory agrees, so let's see if you guys are right. So we've got a 5h plus 4 equals 5, and then instead of h, I'm going to write 1h plus 1, and then instead of minus 1, I'm going to write plus negative 1. And so as soon as you've got parentheses, you always distribute. And if you write down these steps every time like I'm doing, you'll start to see the patterns, and you'll start to see what the steps are, because you do the same thing over and over and over again. So the left side, we're not touching the left side in this case, so we still have 5h plus 4. And then on the right, I'm going to have 5 times 1h, and I'm going to just do that multiplication in my head. So that's 5h plus, and actually, let's keep my color coding. Then we do 5 times 1, which is 5, and then plus negative 1. So you can see as you start looking ahead here, and you can even kind of see it from the very beginning, is that when we add on the right side, we're going to 5 plus negative 1, that's going to give us 4. So before we do any adding and subtracting on the other side, on both sides, we want to just combine like terms. And so that gives us 5h plus 4 equals 5h plus 4. Well, the left side is identical to the right side. So at this point, even though we haven't finished solving, we have an identity equation, which is exactly what you guys identified, because the left side and the right side are identical. And so that means we're going to have infinite solutions. Our solution is all real numbers. Now let's say you didn't notice this, you know, because not everybody looks ahead and thinks about this. They just get into the habit of solving and they don't even think about it. They're just like, okay, next step, let's move the h, you know. So let's say you didn't stop and you're like, okay, next step in the solving. We want to move our variable to the left. So I'll just literally write that down. Move the variable to the left. It's the addition property of equality. So I've got a positive 5h on the right, so we do the opposite. So we're going to subtract it. And then 5 minus 5 is 0. So we don't write it. And then we've got 4. And then 5 minus 5 is 0. We don't write it. And we have 4. So we have 4 equals 4. So you get, again, the left side identical to the right side. And so even if you continued solving, you can still get to a point where you realize you have an identity equation. And as soon as that happens, no matter where you figure that out, that means there's going to be infinite solutions. It doesn't matter what the variable is, what number is for h, you're always going to get something that's true. And so the solution set would be, I believe they just want you to write the real numbers, or the set of real numbers, I believe is how you're going to be putting it in online. But I usually just write my little r thing because it's way quicker. So you guys were both correctly able to identify that this was an identity equation. So let's take a look at this one. We've got 7x plus 3 equals 6 times x minus 2. So you may have already guessed, we've seen a contradiction, we've seen an identity. So just by eliminating your options, this is probably going to be conditional. And I can identify this as conditional immediately because I'm going to have a 7x on the left, and when I multiply it to 6x on the right. Because there's a 7x and a 6x, they're not going to be the same, they're not going to cancel out. And so that's what I'm looking for, is like looking, are my x's going to cancel? If not, then we have to solve this, we're going to have a solution. Now, I don't recommend trying to solve this in your head because you're going to be prone to making errors. You can say, yes, I'm going to get an answer, but I don't recommend trying to do the rest in your head after that, because that's where you're going to start making sign errors, or you have too many things to keep track in your head, and it's very difficult. So you are going to want to go through the solving process. So let's start by rewriting. So on the left, we have 7x plus 3, and then we have 6, and then parentheses 1x plus negative 2. And so we're going to distribute. So the left side is still 7x plus 3. And don't try to skip writing the left side thinking, well, the left side's not changed, I'm going to, not write it down. If you do that, you're going to start getting confused with what you've got going on. So even though it's not changing, rewrite that left side. Then on the right, I've got 6 times 1x, so that's going to give me 6x. And I do recommend doing some sort of color coding like I am. If you do all of your distributing in different colors like I am, it's kind of easier to see what you multiplied, so you know if you made an error. So like 6 times negative 2, you can write negative 12. So you can kind of look at, okay, what numbers did I get when I distributed? Let me just double check that those are the numbers that I want. The only fun part of algebra is color coding. I use color coding all the time because it makes it easier to check your errors, and it's because otherwise, you've just got a sea of the same color on your paper. Now, there are erasable pens out there that you can use if you're a pen person. You can use highlighters. You can even use colored pencils. Some people use colored pencils to do their color coding. Whatever is, whatever is comfortable for you, but I do highly recommend it because, it's a visual thing, so you can see what's going on, versus when you've just got everything in pencil, I feel like it just kind of blends in. It's kind of hard to see where things are. Everything just looks the same. So now that we've distributed, we don't have any simplifying that we need to do. We don't have any like terms to add. So now we need to move the x. So I'm going to just abbreviate it, move the variable. And so I like to move it to the left. And so, you can choose a different color for this part when you start moving things. So a positive 6, we need to subtract it. And then, you know, if it's easier, you can even keep the color coding here, like 7x minus 6x is 1x, and usually we just write x. And then you can go back to your other color and drop down everything that's not changed. So I have plus 3 and then negative 12. And then step 4 is to move the numbers, which I'm going to just abbreviate with our number symbol. And so let's say you pick a different color for that. So I've got a positive 3. Now that I have my x on the left, I need to get rid of everything that's on the left side that's on the same side. So that 3 has to go. And so it's positive, so we're going to subtract. So then I have x equals, and then negative 12 minus 3 gives us negative 15. And so online, you would write your answer, because I believe most of them just ask for solution set. So you'd be writing it with the curly braces and then putting negative 15 inside there, saying that the solution to this equation is negative 15. And you can always check your answer by taking that negative 15, replacing it for x on the left and right, and then following the order of operations on both sides. So when you're solving, you can always check if your answer's correct. And when you're doing things like on paper, like for the homework, I would recommend checking your work. Now on the quiz, you may not have time to check your work, but if you have extra time at the end of the quiz, you can always go back and double check that your answers are correct. Are there any questions so far? All right. Okay, so here we've got 3y minus 1 equals 1 plus 3y. So is this going to be conditional, identity, or contradiction? This one should be actually easier to eyeball because we don't have any distributing to do in your head. Remember that conditional means that there is an answer. So actually I should write that here. This is this one that we have here. This is conditional. I forgot to write that. So conditional means there's an answer. Identity means the left and the right side are identical. And then contradiction means that you're going to get a contradiction when you're solving, basically. They're not identical. So Christy says contradiction. So when we're looking at this, and I look at this, I say, okay, I've got a 3y on the left. Gregory agrees, concurs that this is contradiction. We've got a 3y on the left, a 3y on the right. So as soon as I've got that same thing on the left and the right for the variables, I look at the numbers to see if they match. So even though they're both 1, one's a minus 1 and one is a plus 1. So they're not actually identical because we've basically got a negative 1 on the left and then a positive 1 on the right. And so that makes this a contradiction. And this is kind of tricky because if you're not really paying attention, you could be like, well, they both have 3y, they both have a 1, so they must be identical. But those signs really do matter. And then even though they're in a different order, the order there doesn't matter because we learned from our properties that the commutative property, the order of things don't matter when you have like addition. So if we had rewritten this as 3y plus negative 1 and then 1 plus 3y, that order, it doesn't matter that one has the y first and one has the number first, because you can still look, does the left side equal the right side? And those 3y's, basically those would disappear and you're left with a negative 1 equals 1. And so that is a contradiction. And not a contraindicated. Contraindicated sounds like you've been spending too much time in the medical field, Christy. I think that's used a lot in medicine, if I'm remembering correctly. So this is a contradiction, and so our solution is basically the empty set with the curly braces. So good job with that. Actually, I think the next example that I have is going to be too easy, so let's go to my last one here. So this is I have two examples. The second one was very similar. So and I thought I added one with fractions, but I might have forgotten to save because I don't see it on my PowerPoint, which is too bad because I really wanted to do one with fractions. I don't know what happened to that, sadly. I could turn this into fractions. Let's turn this into fractions because I can do that. They weren't too bad. Because I remember there was like fourths and eighths. So let's do that. Okay, so we're going to just turn this into something with fractions because I meant to have one with fractions because you know that it's good to know how to solve an equation with fractions. So instead of, actually, let's not make 2 fourths because that just reduces and the 4 eighths reduce. So let's use 3 there. So let's say we have 2/3 times q plus 3 equals 4/3 q plus q over 4 minus 9. So when I look at this, as soon as I've got stuff with fractions, I don't even attempt to decide whether this is conditional identity or contradiction. Because with fractions, you got a common denominator. It's a lot harder to kind of eyeball it when you've got fractions. So I wouldn't even attempt to figure it out ahead of time. I would just go ahead and start solving. So as with anything, we're going to rewrite as our first step. So I've got 2/3, and because we're dealing with fractions, any whole number, it's best to write as a fraction so that when we do the multiplication is easier. So instead of q, and you'd have 1q, but let's just write it as 1/1q. So we have a fraction there. And then instead of 3, we're going to write it as 3/1. So just any whole number will be written over 1 to make it a fraction because it will just make things easier when we do our multiplication. And then I've got 4/3 q, and then I've got q over 4. That is the same as 1/4q because it would be a 1q, and then plus a negative 9/1 because I'm going to make that a whole number. So I've just turned everything into a fraction just to make the math with fractions easier. Now, one of the things we learn when we have equations with fractions is to eliminate the fractions, but you want to distribute first before you do that step because I see a lot of people making mistakes and if they do the elimination of fractions before they distribute, they tend to multiply too many times and then they get a wrong answer. So I would recommend distributing first before you try to get rid of fractions in the equation. And so we're going to do 2/3 times 1/1q. That's basically, it's just 2/3 times 1. So we're going to get 2/3 q. That's easy enough. And then if you're someone where you're not particularly great with fractions, I would recommend writing out what you have with the fractions. So we would have 2/3 times 3/1. So I would recommend actually like writing that out. And if you want, instead of parentheses, you can use the dot. And you can see that our 3's are going to cancel there. So we're going to be just left with 2/1 here when we multiply, because the 3's will cancel. So you can just kind of eyeball that when you're distributing. Or make sure you write that down. And then we've still got 4/3 q plus 1/4 q plus negative 9 over 1. And then if I just simplify, I have that 2/3 q plus 2 over 1 equals 4/3 q plus 1/4 q plus negative 9 over 1. Oops. Put too much. There we go. And put the negative in front there. Okay. Now let's eliminate fractions so that you don't have to worry about trying to add fractions and everything. And so we need to figure out what the common denominator is. And you're looking for the common denominator on both sides. So we're going to eliminate fractions. So we look, our denominators are 3, 4, and 1. And you don't have to use the smallest denominator. You could just use the first number that you think of that they all have in common. Which in this case, I would think of 12, and that is the smallest number that they both have common. So our common denominator, or the least common multiple of the denominators, the least common divisor or denominator LCD, is going to be 12. So we're going to multiply everything by 12. And so because we're dealing with fractions, you can just write these all as multiplying by 12 over 1. And you're going to multiply everything by 12 over 1. So color coding can really help here. So you can make sure that you put that 12 over 1 in front of everything that you've got. Well, normally I would write it with like parentheses so that you're distributing, but you basically have to write this step anyway. You just have to remember that everything gets multiplied because we're allowed to multiply both sides of the equation by the same number, and so that means everything gets multiplied by that same number. And with that adding the negative 9, I can just put the negative in front of the multiplication part, and then put the numbers together. So almost don't have enough room here. Okay, so now I've added that 12 that we've multiplied in front of everything. And this may seem like overkill to you. I'm just showing more steps than maybe you may do as you get better at this. And if you're really struggling with finding out, if remembering where the equal sign is, like maybe, because you just see a big long string of stuff, so then maybe you want to make your equal a different color or something. So, oops, I meant to grab a different color. You know, if it starts to get lost on where the left side and the right side is, maybe you want to just change that color, because when you start having fractions, it does kind of get lost. Sometimes it's kind of hard to see where everything is. Some people will make sure the equals always like lined up and then line things up from there, but sometimes that's hard to do if you don't know how much space you need. So maybe just color coding it can help. So when I do my multiplication, I actually will try to simplify these fractions so that I don't do the full multiplication. So I try to like divide out common factors. So like if I work from left to right, I've got the 12 times 2 over 3. I know that 12 divided by 3 is 4. So that can become a 4, and then that 3 disappears. And then on the bottom, I'm just left with 1. And so it's going to give me a whole number. 4 times 2 is 8. And then here, the over 1 doesn't matter. We're going to have 12 times 2, which is 24. Same thing here. I've got 12 divided by 3, so that gives me a 4. And then 4 times 4 is 16, so we're going to go 16q. And then 12 divided by 4 is 3. So I'm going to 3 on top, 1 on the bottom, so I'm going to get 3q q. And then these are both over 1, so it's 12 times 9, which that I don't have memorized. That one I actually need a calculator for. 108. So I try to simplify my fractions as I go to make sure that I have my whole equation correctly here. So we've just eliminated all of the fractions, and so now we're in something that's a lot easier to solve. And I need to add myself a blank slide because I'm running out of space here. So step 4, now that I've gotten rid of fractions, we want to combine like terms. Because I do have some things on the right that I can add together. I've got the 16q and the 3q that I can add together. So I've got 8q plus 24, and then 16 plus 3 is 19. So we have 19q plus negative 108. So now that we're here, I can look at this and I know for sure that I'm going to get a solution. It's probably going to be a fraction. It's probably going to be gross because I made up these fractions in order to do a fraction problem. But there will be a solution because I've got 8q and 19q. They're not going to cancel out. So now we need to actually do the solving process, which I have to go on to my next slide. So I've got 8q plus 24 equals 19q plus negative 108. So I'm going to move my q. What step is this? Step 5. So we're going to move the variable. So some people teach to move the smallest variable. So you would move the 8q instead of the 19q. But it really doesn't matter whether you use the left or the right. Let's actually do that. Let's do it that way because we haven't really moved any negatives, and so that way we have to move the negative 108. So far, everything we've moved has been positive. So let's move the 8q instead of the 19. So that's positive, so we're going to subtract 8q from both sides. 19 minus 8 is 11q. So 24 equals 11q plus negative 108. And now let's move our number. So now let's move the 108. And so if it's negative or you see a minus, you do the opposite. So we're going to add. So we're going to add 108 to both sides. So 24 plus 108, 11, 12, 2, 3, 132. So we got 132 equals 11q. So now that you've done your addition on both sides and you just have something equals something, then you always do your division. If it's a fraction, you multiply by the reciprocal. Here, we just have a whole number, so we're going to do our division. And you always divide by the number that is in front of the variable. So we're dividing both sides by 11. And I think we might have gotten lucky. Does 132 divide by 11? We got lucky, and it does come out to a whole number, which most of the time when you make up a fraction with make up an equation with fractions, it does not come to a whole number. So we got lucky here. This actually comes out to a whole number, 12. So our answer, our final answer to all of this is 12. So that is our solution, and this is a conditional equation. Are there any questions? Okay, that's a firm yes. Ask your question. Does it matter that you move the numbers before the variables? No. If you want to move the numbers first, you can. You'll get the same answer in the end. I just personally prefer to move my variables first, but you can move the numbers first if you want. Are there other questions? All right. So that is solving in a nutshell. So basically, use guys. I've never said that before in my life. I just said it. So you guys have an example from the north. I did live in Michigan for quite a while. I must have picked that up from there. So now you've got examples of solving, all the different types of solving. And now you know how to tell if it's going to be a contradiction or identity, or if you're going to get a conditional. But most of the time you end up with conditional equations. So, all right, so that's all I've got for you guys. Just a heads up, I'm going to be sending an email about this tomorrow. I am actually going to be taking vacation for week 4. So there is, everything in the class is going to work as normal. You're still going to have, assignments and everything. There will be somebody covering for me. So it's not like you're going to have no teacher. You're still going to have a teacher. So I'm going to be gone entire week 4. This is the first time I've been able to go somewhere since the pandemic started. So it's like I'm finally fully vaccinated and I want to be able to see family. So I'm like, I haven't seen them since December of 2019. So I'm taking advantage of it while I can. So just a heads up, so there will be no live next week because I will be on vacation. I'm still going to be checking Remind and sending messages through Remind. I will not be really checking my email all the time, so you'll want to go to the guest instructor for that. But I just wanted to give you guys a heads up, and then I will be back for week 5, and everything will go on like normal. So yeah, I'm looking at it's. I'm actually going to be babysitting my niece, who is 14 months. Her daycare got closed because one of the babies got COVID, and so now my sister and brother-in-law, who are working from home, have no one to watch her because she can't go in daycare because the daycare is closed because of COVID. So that's another reason why I'm going to visit, is basically to be the babysitter for a week. Your coverage is going to be George Vaughn. He's the one that's been grading the tests, the quizzes and stuff. So he grades those because we have a grader, so I can do the lives. And so he's just going to be doing the rest of the class. Yes, George. So you've seen his name on the quizzes, so he's going to be taking over. He's a good guy, knows what he's doing. He's good at the discussions. Like I think you guys will be fine with him. He's been logging in daily, so you'll be in good hands. So, all right. Well, I'm gonna call this session done. And if I have time before I leave, because I do want to make sure I get the course set up with announcements and everything before I go, if I have time, I may pre-record something for next week, but it will depend on how much time I have as I'm trying to get everything set for being gone for a week. So I cannot guarantee that there will be a pre-recorded video, but if there is, I'll put it in the announcements. So, all right, so you guys enjoy your Sunday night, and I will see you. Well, I'll talk to you guys in the discussions for the next 2 days, and then I will see you a week after that. So take care, and yeah, I'll talk to you guys later. So you're welcome for all of this, and I'll see you later. Bye.